Hello and welcome to Unit 1 video on quadratic functions. Fun fact, I recorded this entire video all about quadratic functions with no sound earlier today. So that was pretty entertaining. I was really mad when I opened up the video and tried to edit it. So we're going to try it again. In this video, I'm going to help you identify key characteristics of a quadratic function from the graph. And I'm going to help you understand how the graph of a parabola is related to its quadratic function. And then I'm going to use some of these other concepts in another video. So the first thing is I just want to show you some key characteristics from the graph. This is a graph of a quadratic function. I'm going to give myself the ability to highlight some stuff here for you while we talk about it. So this is what the graph of a quadratic function looks like. This is a parabola. And there are some key points that we're going to ask you to be able to identify so that you can graph it and that they're just going to be relevant when we solve word problems and stuff like this. So one of those points is the vertex. It's this little dot here at the bottom of the U. So this point is also sometimes called the maximum or the minimum value. Let me draw an arrow so we can see that. So this point on your vertex, this x, y, whatever it is, the y is either your max or your min value, and it occurs at the x coordinate here. So maximum or minimum value, in this case, it's a minimum value, because when you look at the entire graph, when you look at the whole shape that we have here, this whole parabola, the lowest point is that vertex. The lowest point is the vertex, and that's what makes it the minimum value. Right there. If this parabola were upside down, if I had a parabola that was shaped like this, and this was my vertex, why then that would be the maximum value at the vertex. We'll do some more examples that will show that a little bit here. But the vertex is important. Knowing that it's the max or the minimum value of a function is important, and it will help us when we're graphing and when we're doing word problems. The other thing I want us to pay attention to is I want us to pay attention to the x-intercepts and the y-intercept. So the x-intercepts, which I'm going to highlight here in red, in this case, our x-intercepts would be the points 3, 0, and the point -1, 0, here and here. These are where you cross the x-axis. So where your parabola crosses the x-axis, those are your x-intercepts. And those are valuable sometimes in word problems. They're really valuable when we're graphing. And they are valuable in that we know they're related to the quadratic formula. When you get the zeros of the quadratic formula, those are the x-intercepts. And then we also have, I'll highlight in blue for you, the y-intercept. Just like the x-intercepts cross the x-axis, the y-intercept crosses the y-axis. And we'll be able to find that point here. One cool feature, I'm going to clean this up for a second so I can tell you a little bit about the axis of symmetry. The axis of symmetry is this dotted red line that we have here, going down, up and down, cutting through the parabola. So this is called the axis of symmetry. Let me highlight that for you in yellow. Axis of symmetry. And symmetry, symmetrical, is the property that this parabola has that when I cut it in half, like imagine I took a pair of scissors and I just zoop, I cut this right down the axis of symmetry. My left half of the graph and the right half of the graph look exactly the same. They look exactly the same. They reflect each other. If I cut down this dotted line, I would cut my parabola into two equal shapes that would be exactly the same size and the same shape. And that's a little bit about what it means to be symmetrical. We're going to study that more this semester. Another way that you could think about this, I like to do, sometimes if we're lucky enough to have in-person classes, I'll do it this way. If I printed out this picture if I printed out this picture on this sheet of paper, and then instead of cutting down that middle line, let's say I folded right here along my axis of symmetry. I creased my page right here, and I folded it in half. This point on the parabola and this point would touch. My x-intercepts would touch. This point and this point would touch, right? I could fold it perfectly in half, and then the left side of the parabola and the right side of the parabola would overlap completely if I folded down that line, down that axis of symmetry. And that's one thing that that's another way that you can kind of imagine symmetry. So when you see a graph of a parabola, I would expect you to be able to label each of these points and to know what those are. So in lecture, if I say the axis of symmetry or the x-intercepts, I hope that you'll be able to visualize this or refer back to your notes and kind of see what we're talking about here. So that's enough of the basic features of the parabola. I feel we can check that off of our to-do list. We can now identify key characteristics from the graph. So our second item that I want us to be able to accomplish is to understand how the graph of a parabola is related to its quadratic function. How are they related? So first of all, we need to remember what the quadratic function is. So what I'm going to show you is something called the general form of a quadratic function. And it looks like this. So let's see, f of x is equal to ax squared plus bx plus c. And in this equation, a, b, and c are all real numbers, and a is not equal to 0. If you pay attention throughout this video series, you'll figure out why a should not be equal to 0. And hopefully we'll have a little bit of time to talk about this in lecture. Why can't a be 0? So this is the general form for a quadratic function. And what we're going to do is we're going to go through, and each of those key characteristics that we looked at, we're going to find a way to relate and find those points, x-intercepts, y-intercepts, axis of symmetry, all of that stuff. We're going to find a way to relate that to the values of a, b, and c. So that then we'll be able to look at any quadratic function that's in this general form, and we'll be able to graph it by using some formulas for a, b, and c. All right. I'm going to page over to a graphing utility called Desmos and show you a few things. Desmos is free. It's free. It's a free online graphing calculator. And you might want to use it throughout the semester to help you figure out how to graph things, what things look like, give you a visual way to look at problems. It's also integrated with your Lumen online homework. So whenever you ask for a graphing calculator and Lumen gives you a graphing calculator, it's based on Desmos. So you should have some familiarity with how to use it. But I'm going to show you what the general form of a quadratic function looks like on Desmos, and we're going to play around. I'm going to change the values of a, b, and c so we can see what that does to the generic form. So the first thing when we look at it, I'm going to set a equal to 1, b equal to 0, and c equal to 0. So our general equation, ax squared plus bx plus c, is actually going to be 1x squared plus 0 times x plus 0. And then, of course, these we can simplify away. And so we'll be looking at this example to start with. F of x is equal to x squared. And then as I change our a, b, and c, we'll change that graph a little bit. So let's take a look. Here's my beautiful Desmos. And here is what the equation looks like when I have b and c set equal to 0 and A is equal to 1. So let's take a look at those key points here. We have our vertex down here at the bottom. And we have our axis of symmetry, this little red dotted line through it. Notice our x and y intercepts are not labeled at this point. Where does this graph touch the x-axis? It actually touches it right here at the vertex. That's the only place that we touch the x-axis is at the vertex. So here, our x-intercepts and our vertex is the same point. The same thing is actually happening with the y because we're touching at the point 0, 0, where the x and the y-axis touch each other. Our vertex is also our y-intercept. So that's kind of interesting here. Our vertex, our x-intercepts, and our y-intercept are all the same value here. And we still have that axis of symmetry that cuts right through the vertex. So now I want to show you what happens. We're going to start off by changing the value of A. So here A is equal to 1. And if you see on the left side here where I have this menu that I keep popping in and out, at the very bottom, there's a line that says A equals 1, B equals 0, C equals 0. Those are the coefficients. Those are the A, B, and C values. So what I'm going to do, there's a little play button next to A equals 1. I'm going to push play, and we're going to see what happens as A increases to 10. Then it's going to bounce and start decreasing again back to 0 and then down to negative 10. And I want you to watch what happens as we do this. So we're increasing. Now we're decreasing again. Whoa, and now it's negative. One of my students in my class last semester said, "Sarah, are you trying to hypnotize us?" I said, "Yes, I am. I'm trying to hypnotize you. Study early and often for all exams." So take a look at what's happening here with the A value. When A is negative, my parabola opens downwards. And when A is positive, my parabola opens up. So that's one thing that's happening. Another thing that's happening that I think is really interesting, the farther away A gets from 0, the skinnier that parabola is. The closer A gets to 0, the fatter that parabola is. So I think that's interesting. And that's what's controlled by the quantity A. That's what happens when we get A. So I'm going to stop A right here at negative 4.73. This is still a parabola. We still have a vertex. We still have x and y intercepts, although they're all still at that one point. I wonder what will change it. I'm going to now change the B value. I'm going to push play on the B value, and it's going to do the same thing A did. It's going to increase to 10 and then decrease to 0 and then down to negative 10 and go back and forth. So now we're going to change the B value here and watch what happens. Oh, crazy. I'm going to label our x and y intercepts so that we can see. So what's changing right now? Looks like my vertex is changing. My x-intercepts are changing. But my y-intercept is staying the same. That's so interesting to me that my y-intercept would stay the same. It's not moving at all. Everything else is moving. So B, it looks like, has to do with our x-intercepts and our vertex, but doesn't have really much to do with our y-intercept. Interesting. All right, I'm going to stop our B value right here at negative 8.035. And last but not least, we're going to take a look at C. What happens when I change the C value? Okay, just as before, we're going to increase to 10, then decrease down to 0, then past 0 all the way to negative 10, and we're going to go again. Ready? And here is the C value changing. Ooh, I want to stop it right here. Notice, does this parabola have x-intercepts? It doesn't. It does not touch the x-axis anywhere. There are no x-intercepts here. There's still a y-intercept. There's still a vertex. There's still an axis of symmetry, but we no longer have x-intercepts. Interesting. Okay, I'm going to keep playing. Now C, the C value is changing our y-intercept. Ooh, I'm going to stop it right here. Now we have x-intercepts again. We have x-intercepts again. So it looks like C is mostly changing the the y-intercept. It's changing the x-intercepts. It's changing where I'm placing my parabola. Where I'm placing it in a sort of vertical direction, it looks like. Interesting, no? I like to ask questions to the video. Hopefully you guys are watching and going, yeah, Sarah, that's so interesting. You're the best. We love it. So that's interesting. Here we have no x-intercepts. I am going to do one more example with no x-intercepts. I want you guys to see something. So let me pause it right here. If I change and make this parabola open up, I'm going to make this parabola open up. I'm going to move it up. That was crazy. I didn't expect it to change like that. Huh, interesting. I'm going to keep moving it up so that it opens up. And I'm going to move it even higher up here. Notice this parabola does not have any x-intercepts also. So it is possible to have a parabola with no x-intercepts. One question I have for you that I'm wondering about is it possible to get rid of that y-intercept? Just looking at all the ways I can change it. What do you think? Let me know in the comments. Is it possible to get rid of that y-intercept? Leave a comment and tell me what you think. Can we get rid of that y-intercept? And if nobody comments on the video, you don't want to come to lecture because I'll be sad. All right. So that's enough. And I want to point out one other thing. I've been changing A, B, and C. Look at all of these other values that I have here. These are each equations representing each characteristic of the parabola. So this x is equal to negative b over 2a. That's the equation of the axis of symmetry. So when I plug in my b and a values for this particular parabola, it gives me that axis of symmetry. And those of you who remember the quadratic formula, you'll notice the x-intercepts are related here. And this y-intercept is related to formulas as well. So I'm going to page back to Desmos and copy down those formulas so that you can see exactly what those are for your notes so that you can have those there. And then we'll be able to use the general form of the equation to graph anything we need to graph. All right. So this part here is just to make sure that you have your notes. If you already have this in your notes or you already feel confident about it or you're going to get it from the textbook, you don't want to follow along in the video, that's fine with me. You can skip ahead a little bit. But I just want to make sure you guys have in your notes these general things. You need to know that the axis of symmetry is given by x is equal to negative b divided by 2a. The equation of a vertical line going through this point. And you need to know that I'm going to find my vertex of my parabola. The x-coordinate is going to be that negative b over 2a value. And then when I want to get the y value, I'm just going to plug that in to my function to get my y value. This will be the equation of the vertex. And our x-intercepts, we will use the quadratic formula to find them. And so the x part will be negative b plus or minus the square root of b squared minus 4ac all over 2a, comma, 0. And we'll get 2 points out of that. Sometimes we'll have 2 x-intercepts. Sometimes we'll have 1. Sometimes we'll have none. So one question I'd like you to think about. What happens to this formula when there are no x-intercepts? What happens? You might know from a previous class, you might have to figure it out, but it is something I'd like you to think about. All right, and those are our x-intercepts, and to find our y-intercept, this one's nice, I think. It's one of the ones that's not so difficult to calculate. You put in 0 for the x-coordinate, and then you plug that in for your y-coordinate, and that'll give you your y-intercept. A note is that if our a value is greater than 0, the parabola opens up. I'll draw a little picture to help you know what that means. The parabola opens up, which means we get that nice little U shape. If a is less than 0, then the parabola opens down, like so. Forgive my artistic skills. I'm trying, you guys. And so now we have everything we need to be able to draw the graph of a parabola when you're given the standard form. So that's what I'm going to show you in the next video. This one's already been a little bit long. So stay safe out there, and I'll see you in the next video.